And we finally get to the final video of section 3.5. And here we're going to actually begin with reflections. Now, reflections are the only ones that truly don't just fit into the same rules that if it's directly connected to X, it behaves one way or the other. You're just going to have to learn the set of rules on this. And reflections simply mean there's negatives involved. And basically, if the negative is directly associated with the X, it reflects over the Y-axis. If it is not directly associated with the X, then it reflects over the X-axis. So in that respect, I guess it's somewhat similar. If it is connected to the X, it goes over the Y, and if it isn't, then it goes over the X. So what we have going on here, for example number 11, we have f of x equals negative x cubed. And once again, it certainly appears that this negative here is directly associated with x. But once again, we look at what does the 3 affect. The 3 only affects the x and not the negative. So negative is not directly connected to the x, and so our parent function is the cube function. And then since the negative is not directly associated with x, then that means it's going to reflect over the x-axis. So we remember our cubic points: 0, 0, 1, 1, negative 1, negative 1, 2, 8, and negative 2, negative 8. And then this says reflect over the x-axis. So if I reflect this over the x-axis, it's going to come way down here. Reflect this over the x-axis, reflect that over the x-axis, reflect this one over the x-axis, and finally reflect this over the x-axis, and we get this. And then my new graph becomes this shape. It's just an inverted cube function. And there's absolutely nothing wrong with that. It's just the way it is. Example number 12. F of x equals negative absolute value of x. Now once again, it should be obvious that this is the absolute value function. That shouldn't be too much of a problem. Now we ask, is the negative associated with the, or directly associated with the x? And the answer is no, it isn't, because it's clearly outside of the absolute value. So that means we're going to reflect over the x-axis. So absolute value, if we remember, first of all, looks like a V, and the points would be 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2, and we know it's going to be in the shape of a V. But we have to reflect each one of these over the x-axis. Reflect this over the x-axis, we get there. There, stays right where it's at. Reflect this over the x-axis and reflect that over the x-axis. And so what we do is we get the inverted V, or negative absolute value of x. And the final example in this section of graphing and graphing and graphing. We get one good problem to end it all. First thing we need to do is we need to find what is the parent function. Parent function, we're taking x and we're squaring it. So that means it is the square function. So I should be able to come over here, and I've got the points 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. Now here, since there's going to be lots of things going on, I want to make sure that I do them in some particular order, or if I can get my vertex at the right spot and realize what I need to do from that point, it's going to be easier to do it that way. So let's try that method. Okay, I look at this, the plus 1 right here. This plus 1 would mean I need to go 1 logically to the right. but since it's connected to the x, I'm going to go 1 to the left. This plus 3 says I'm going to go either 3 up or 3 down. It's logical. 3 up. This 2. This 2 is not directly connected to the x, and so therefore there will be a stretch my y by 2, and this negative out here tells me I need to reflect over the x-axis. And so I have several things I need to do. Now the first thing I'm going to do is I'm going to do this shift with just the vertex. I'm going to go 1 left and 3 up. So that puts me right at that point there. And I'm going to create a whole new set of axes, because now I can treat this as if I've done all the shift here, but now I just need, and so my original points would be here, and then up 1 over 1, over 2, up 4, you know, the same, it's going to be the same, except I need to do a couple things. First of all, I need to stretch by 2, so stretching this one by 2 would go up to 2, but then I have to reflect it over the x-axis, which will put me down to right there. If I do the same thing here, when got the negative 1, 1, stretch it up by 2, so it's going to become up to 2, and then I have to go down by 2, so there's 2 points. Then I would have 2, 4, stretch it up by 2 is 8, and then reflect it down here, and so I'm going to be down in this general area about right here. And then likewise, the final point's going to be there. And so what I'm going to get is I'm going to get a parabola that looks pretty much like that. Due to me being off and not having a good square grid, I am a whole lot fatter than I should be. It should be about half as fat as it started out because I stretched it by 2. Reflecting over the x, I should have it going down, and the vertex, everything should be shifted 1 to the left and 3 up, and it is. If this was the original vertex, I've shifted 1 to the left and 3 up and gotten it there. So everything falls into the place. But you do need to be careful and make sure that when you actually have a grid or graph paper, you can actually get these a whole lot more accurate.